Okay, so yeah, I'm really honored to be here, and I'm going to talk a short bit about amplifying human abilities. And let me start with something looking back in history, because I think looking what you achieved in the last 10 years is really something that we should take as an example to look at what innovation can really do. And I think if we look back 100 years, in 1921, there was no penicillin, there was no traffic lights, there were no transistors, there were no rockets. And what we have seen over the last 100 years, it has really changed how we live. It has changed society. And a lot of the worries we see nowadays, be it climate change, be it global health, I think a lot of those questions, they cannot be solved with current technologies. They cannot be solved with the technologies we have now. They cannot be solved with what we know now. If we don't innovate, we're not going to solve this. And I give you one graphic example for that. So there's a German book, The World in 100 Years, which was published around 1910, so a bit over 100 years ago. And there was one page on space tourism, on tourism to the moon, they called it at that time. And that's how they imagined it, basically with a balloon and a big, yeah, from a ship. So, and I think this is what we've seen sort of over the last 100 years. And now just recently, we have seen sort of this start of space tourism for real. And I think if we talk, for example, something about climate neutral mobility, this sort of is very much what I would consider the sort of flying with a balloon to the moon. And if we don't innovate, we're not going to solve mankind's problem. And I think this is something where you have given a great example now with basically what people can achieve in a short time. And so I think it's really important to look forward and not to look backward to innovate. And I think many of you have probably seen the World Sustainability Goals, and very often computer science is not really at the center of this discussion, but in my view, it really should be, because I think we have a lot of the tools, we can do that. And how does this link to human augmentation? So what we see is if we change people's abilities, they can change what they do. They can really make a difference. And for this, I'm now giving a very short overview of some of the topics we are looking in the lab. So research directions and goals we were looking in. So I think I picked out 4 points which I found interesting and where I also see quite a link between what you're doing and what we are doing. So I think one of the things we are really excited about is increasing the bandwidth between humans and computing systems. So how can we increase the information intake in people and potentially without increasing cognitive load? We work there on sort of speed reading, forced speed reading, etc. I think that's something, it's not solved, but it's a really interesting problem. The second one I want to pick here is externalizing human memory and further cognitive functions. So I think here you see an experiment Passant is doing, where we look at sort of live logging in human memory alterations, how we can change how we remember things. Again, this is, I think, a field that just is starting. And if we have seen what having books has done to mankind, that we can really record things. And now I think this is really at this point where if we go to digital human memory extensions, I think we'll really see a great growth in abilities. One more, and that's where we are currently working on a bigger project, is the amplification of human perception, enhancing human perception. Here is just one prototype where we look into if we give people more sense of depth, a wider spectrum, what does it do to us? What does it do? How does it really change us as humans? And the final one, which I think is really interesting also on a global scale, empowering people with different cognitive abilities or with cognitive disabilities. I think something we have done here is really giving people guidance in place in this case, they can build very complex structures without really reading instructions. And here I think there's again something really big we have the potential for by empowering people by using those technologies. Oops, I forgot. I have two screens. Sorry, this was, sorry, I switched on the wrong screen. This was showing perceptive enhancements and amplification, mainly depth camera and thermal imaging, like widening the spectrum, and the other one here, empowering people with cognitive disabilities, really giving people an ability to do things they couldn't do before, and not just on a physical space, really on the cognitive side. And now, what are the fundamental challenges? We haven't seen much. Also in our lab, we have really, I think we have, a lot of us have worked on this question of how do we create new realities? So how do we really mix the realities, how we create a reality where it's really hard to tell where we are? But I think this is only sort of the overarching goal. I think there are a number of really fundamental challenges that we haven't really come very close in our community. So one is moving interaction closer to the body or into the body. And I think we have seen over the last 10 years some examples, but it's, if you look at big conferences like CHI, it's still something which is really typically the odd one out. And I think this is really a question how we go there. It has a lot of ethical implications. A second one, which we have been now looking more into, and I come towards the end of my talk again into that space, how do we make systems safe and secure? I think we haven't even managed to make our computers, our mobile phones safe and secure. How are we going to make systems safe that are part of our body? And the final one in that space here is something we have started a number of projects. It's about long-term human benefit. And I have here this example. If you sit like this person for 25 years, you will have a lot of problems. We are made for walking, we are made for moving. And I think the design of the systems we have seen over the last 50 years in computer science have really created short-term productivity gains at a cost of long-term health problems. So this may be on the mental side as well as on the physical side. And I think one of the big things we look at is really how can we bring movement back into work, how we can bring the outdoors back into work. And you wonder why I have a button here. And I think that's one other thing we have been working now with psychologists. So when you work in the digital space, you very often don't see your results. You have written 100 emails and you feel you have done nothing. If you, and that's what I did, sew on a button to your jacket, is you get sort of an instant reward that you have succeeded, and over the next days you will even remember that you have done something. And I think this is something we'll look at a moment. But this is sort of where we work on. And for a birthday, it's always looking forward, wishing something for the new time, for the next years. And I picked one short topic on keeping humans in control. I think we don't want to make ourselves into people who are controlled by somebody else. And if we talk about assistance, we are very close to manipulation. And I give you an example here. If you look at a shop like this, if you were picking something, you were manipulated by people. They told you what you should buy, but you had a real chance looking around. And I think if you took a day, you probably could look at all things. If we look at something like AliExpress and you look for the term shirt, you have already 200,000 results. There's just no way you can check it out, all of them. So what do? You rely on the search algorithm. Who do you trust with the search algorithm? You trust the people who want to sell you something. And what you have is this selection dilemma. And this is, I put it here now with the example of the clothing, but you can have it with anything where you have a choice. And I think assistive systems very often limit our choice. And typically we cannot do a random selection, so we need an algorithm, and by this we introduce bias that manipulates us and reduces our choice. So on a bigger scale, this looks like this. You have 1,000 or 1,000,000 options, like the 200,000 t-shirts, or a few 100,000 movies to watch, or 10 routes to walk, 10 people to die, 10 million people to date. And what happens is the AI algorithm reduces this to a very small number, and you then choose one of them. And if you look at this, you make very little choice compared to the choice the algorithm makes, but it really feels great. You feel in control. And this is really a tricky one. Once the algorithm has chosen the 100, already most of the choice has happened. And now we know that with manipulation, and you can just take any marketing handbook and you get something like this, you present people 4 items, they feel they choose, but you pick them in a way that you really know which one they choose. And I think this is something in the area where we work in, it's so easy to manipulate. And this brings us to the point, to the close of my talk. Is this the end of serendipity? Who do you trust your future? Who is allowed to build the assistive system? Who is allowed to build your human memory? Who is allowed to make choices for you? And I think our generation still knows these things. Oh, I met her accidentally and we got on well together. It was pure chance that we met, and we sat next to each other and realized we work on the same things. Those things, they are probably from the past. If we get forward with our vision, with assistive systems, with technologies, they may be really from the past. And now I have a few dystopian visions. So basically, who should decide on the route you take? What should you pass? Should you pass the nice places of Munich when you drive into, or the not so nice places? Should I drive you past the Starbucks or no shop? This, you may say, it doesn't really matter. Another one is, what should you eat? That has a long-term effect. If I make you like other things, and again, this is very easy, but the very fundamental thing is basically where we have at the moment recommender systems really going into our lives. And this is a picture of my young self with my wife some many years ago. And if you look at this, Tinder is the same thing as I said earlier. You have 1,000,000 choices. The algorithm picks 200 you can swipe through. Who made the choice? It was not you with swiping. It was the guys at Tinder. And if they have bad, like a bad vision for the world, if they have a bad assistive system, we may end up in a really bad place. And so that's why I think it's really, who do you trust to decide? And I think it's in the end us researchers who are in that space. And I think the movies you watch, you will eventually like. That's not really a big thing, but in the end, which flat you buy or whom you marry is probably really the big choices. And that's why the responsibility we have as researchers is getting really massive. We are really playing with the livelihood of the world. And we are changing reality. Reality is what you perceive and what you interact with. And basically, while we change perception and how we interact, we change the reality. And creating decision support system, pre-selecting options, what we typically do with assistive systems, is really shaping the futures of individuals and society. So it's not that it's the computer science in the basement that does some stuff. We are at that moment changing society. You are changing society. So really take on the responsibility and don't build autoplay for people's life. I think, you know, autoplay from YouTube, etc. Don't do that. Let people be in control. And with this, I like to stop here and wish you sort of all the best for the next 10 or perhaps 100 years.